Ever wonder how your favorite radio station reaches your car's stereo, or how your phone can send selfies from one side of the world to the other? The answer lies in the magic of electromagnetic waves. Electromagnetic waves are waves that can travel without the need for a medium. They consist of oscillating electric and magnetic fields that are perpendicular to each other. These waves carry energy from one place to another at a constant speed in a vacuum, which is approximately 300,000 kilometers per second. The general formula for electromagnetic waves is velocity equals frequency times wavelength. In this formula, velocity represents the speed of the wave, frequency represents the number of waves passing a point in a given time, and wavelength represents the distance between one wave and the next. These three properties are interrelated. The higher the frequency, the shorter the wavelength, and vice versa. The force and energy in electromagnetic waves can be calculated using Lorenz's force formula and an energy density formula. The Lorentz force is the force exerted on a charged particle moving through an electromagnetic field. The energy density of an electromagnetic wave is the energy per unit volume, which is determined by the electric and magnetic fields. Electromagnetic waves have a spectrum that varies according to their wavelength and frequency. This spectrum is divided into 7 types: radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays, and gamma rays. Each type of wave has its specific applications, from communication and cooking to medical, imaging, and scientific research. Now, to consolidate our understanding, consider an electromagnetic wave with a wavelength of 500 nanometers. Using the formula we discussed earlier, we find that its frequency is approximately 600 trillion hertz. Looking at the electromagnetic spectrum, we can identify this wave as blue light. Or consider a charged particle moving at a speed of 1 million meters per second in an electric field of 100 volts per meter and a magnetic field of 1/100th of a Tesla. The Lorentz force on this particle would be 20,000 newtons. Finally, consider an electromagnetic wave with a maximum electric field of 100 volts per meter and a maximum magnetic field of half a Tesla. The energy per unit volume carried by this wave would be approximately 4.43 billionths of a joule per cubic meter. In summary, electromagnetic waves are energy-carrying waves that can travel without a medium. They have properties like velocity, frequency, and wavelength, and they exert forces and carry energy determined by the electric and magnetic fields. These waves form a spectrum that ranges from radio waves to gamma rays, each with its unique applications. Remember, the next time you tune into your favorite radio station or send a selfie to your friend across the globe, you're making use of the fascinating science of electromagnetic waves. Isn't that something to marvel at?